How exactly will an unmanned, airborne heavy-duty truck, capable of taking off and landing on a 200-meter runway, carrying a payload of 3.5 tons, and flying 3,000 kilometers nonstop, revolutionize modern warfare logistics? On March the 31st, the Changying-8 large transport drone, dubbed the unmanned aerial heavy haul truck by the media, completed its maiden flight in Jingzhou, Henan. Based on data from the site, this 7-ton platform, with a wingspan of 25 meters and a length of 17 meters, is redefining the technical boundaries of aerial cargo drones. First, let's look at its takeoff and landing performance. According to public reports, the Changying-8 requires a minimum takeoff roll of just 200 meters. Among manned transport aircraft, only lightweight models like the Y-5, which features a double-wing design, can achieve such short takeoff and landing capabilities. For a transport platform with a takeoff weight of 7 tons, this figure means its reliance on airports has been reduced to a very low level. In military applications, this capability directly translates to enhanced battlefield adaptability. Ground forces no longer need to rely on large, structurally complex, and conspicuous military airfields. Instead, they can simply clear a makeshift runway of just over 200 meters near the front lines, or even a flat, hard-surfaced area, to allow the drone to land and unload supplies. This effectively extends the air logistics supply line directly to the tactical front. In island or coastal combat environments, a 200-meter runway can even be established on certain flat beaches, or temporarily constructed makeshift runways to facilitate takeoff and landing. The second point is its loading efficiency. The Changying-8 has a maximum takeoff weight of 7 tons and a rated payload of 3.5 tons. Its load factor is exactly 50%, meaning half of its takeoff weight is dedicated to cargo. This figure is exceptionally high in aircraft design. By comparison, mainstream commercial cargo aircraft currently on the market typically have a payload ratio of only around 20% to 30%. As the airframe structure, life support systems, and fuel account for a significant portion of the weight, even in the case of purpose-built military transport aircraft, the payload ratio rarely exceeds 40%. The fact that the Changying-8 achieves 50% indicates that its structural design is extremely streamlined, created specifically for efficient cargo transport. This design philosophy is easier to implement in unmanned aircraft than in manned ones, as there is no need to account for the cockpit environment or pilot life support systems, allowing the entire airframe's payload space to be maximized. This payload capacity can be compared to that of the Mi-171 transport helicopter currently in service. The Mi-171's internal payload capacity is also around 4 tons, and it indeed plays an irreplaceable role in vertical resupply. However, in terms of flight speed and range, helicopters are constrained by their rotor systems. Their cruising speed is typically only around 200 km/h, and their range is relatively limited. As a fixed-wing UAV, the Changying-8 has a very clear speed advantage. When considering island landing operations or cross-sea combat scenarios, this type of fixed-wing cargo UAV, due to its high speed, heavy payload capacity, and low runway requirements, is likely to become the primary aerial transport force connecting rear bases with frontline landing zones. Especially in high-threat environments, UAVs do not need to factor in the risk of pilot casualties, allowing them to execute higher-risk resupply missions. The third point is its range and mission flexibility. The Changying-8 has a maximum range exceeding 3,000 kilometers and a service ceiling of up to 8,000 meters. The 3,000-kilometer range is a critical figure, as it signifies that this UAV possesses the capability to integrate trunk and feeder operations. In traditional military transport systems, a 3-tiered model is typically employed. Strategic transport aircraft are responsible for delivering supplies from rear bases to hub airports near the theater of operations. Then tactical transport aircraft distribute these supplies to various forward bases. Finally, if resupply is required for smaller combat units, vertical delivery via helicopters may be necessary. Although this 3-tier system is comprehensive, coordination is complex, and each level of transshipment incurs time costs and labor costs associated with ground loading and unloading. The introduction of the Changying-8 could transform this supply chain. With a range of 3,000 kilometers, it can take off directly from rear logistics centers in many scenarios, bypassing intermediate hubs to reach simple landing sites on the front lines. Its 200-meter takeoff and landing distance allows it to reach areas near battalion level or even company level combat units. This effectively streamlines a process that previously required 3 aircraft and 2 transfers into a single drone and a single loading and unloading operation. This point-to-point direct resupply offers significant improvements over traditional multi-tiered transfer models in terms of both the efficiency of material distribution and the flexibility of logistical support. In time-sensitive resupply missions, such as the urgent delivery of ammunition, medical supplies, or critical components, this capability could directly determine the sustained combat effectiveness of frontline units. When comparing this performance to several previously introduced cargo drones, the Changying-8's technological standing becomes even clearer. For example, the Tianma 1000, which made its maiden flight before the Changying-8, also has a takeoff and landing distance of less than 200 meters, but its maximum payload is 1 ton and its range is 1,800 kilometers. The Changying-8 boasts a payload capacity 3.5 times greater than its predecessor, with a significantly extended range. This means it can transport larger-scale supplies, such as field kitchen equipment, small engineering machinery, or standardized air cargo containers. Another example is the Rainbow YH-1000S, which pioneered a hybrid power technology route, but its payload and dimensions are in a different class compared to the Changying-8. The Changying-8 has truly succeeded in boosting its payload capacity to the 7-ton class while maintaining short takeoff and landing capabilities. Now let's examine its cargo compartment design and loading efficiency. The Changying-8's cargo compartment volume reaches 18 cubic meters and features a through design with dual front and rear doors. This through-type cargo compartment design allows for simultaneous loading and unloading from both ends, eliminating the need to turn around or reverse in confined spaces. According to the designers, the entire aircraft can be loaded or unloaded in just 15 minutes, a figure that translates to exceptionally high turnaround efficiency in the commercial logistics sector. When equipped with standardized air freight containers and refrigerated transport containers, it is fully capable of serving as an aerial platform for regional express delivery, emergency relief supply drops, and even forest firefighting in the civilian sector. In military applications, this rapid loading and unloading capability minimizes the time spent on rudimentary runways, thereby reducing the risk of detection and attack by enemy forces. Another noteworthy aspect is its dual-use design philosophy. From the very beginning of the Changying-8's development, the needs of the civilian logistics market were taken into account. The 18 cubic meter cargo hold is compatible with multiple standard aviation containers, meaning it can seamlessly integrate into existing civilian aviation logistics systems. In the civilian sector, it can be used for express delivery, emergency rescue and supply missions, or even converted into an aerial firefighting platform. When necessary, this civilian logistics platform can be requisitioned or modified in a very short time to directly carry out military transport missions. This dual-use design philosophy enables the technology to reduce costs and accumulate operational data through large-scale commercial operations, while simultaneously establishing a reserve of airlift capabilities for national defense mobilization that can be deployed at any time. Overall, the successful maiden flight of the Changying-8 UAV represents another step forward in large cargo drone technology. With a takeoff weight of 7 tons, a payload capacity of 3.5 tons, a range of 3,000 kilometers, and a takeoff and landing distance of 200 meters. These specifications collectively form a transport platform with practical value in both military logistics and civilian logistics. For military logistics systems, it offers an aerial resupply option capable of reaching the front lines, enabling rapid loading and unloading, and maintaining controllable risks. For the civilian logistics industry, it offers a new, highly efficient, and low-cost option for regional air cargo transport. Its dual-use design strikes a balance between economic viability and combat readiness. As subsequent test flights proceed and practical applications unfold, the Changying-8's performance in real-world operations warrants continued observation.